Welcome to the fourth lecture. Now we start our algorithms for mining different type of patterns. So, the first pattern we will consider is something known as association rules. So, let me explain what these patterns mean. So, the origin of this kind of pattern was one of the earliest use of data mining in the retail shop. Say for example, you have gone to a supermarket, a mall, and you have bought some items. Okay. So, say for example, I note down say the bill after a person has bought something in his basket. You carry a basket and you buy something, and I have noted them down. For example, you can see a table where these rows are the different transactions. So, TID 1 is the transaction ID 1, say the one customer's transactions, as next row is the next customer's transactions, and so on. And along with that, what is noted is that what are the items purchased by that customer. So, you can see that in this table, customer 1 has bought bread and milk, customer 2 has bought bread and diaper and beer and eggs, customer 3 has bought milk and diaper and beer and coke, and so on. So, this type of transactions are called market basket transactions. So, they sort of consist of two parts. One is the ID of the transaction, one particular customer. The second is the list of items purchased by the customer. So, note down this term. So, these things, this milk, bread, diaper, eggs, coke, they are different items available in some store. So, a market basket transaction would consist of a set of items corresponding to a particular transaction. So, I can think of an item set. So, in the first row it is a two element set, bread and milk, and second, third, fourth, fifth row are 4 element sets, 4 item sets. You can imagine that if you sort of look at all the purchases in a supermarket, there will be millions of this kind of transaction entries. There will be millions of entries. So, maybe every day thousands of persons come and do this kind of transaction. So, if you see over a period of say 1 or 2 years, there will be an enormous amount of data, a very large this kind of transaction market basket database, where everything would be noted down. And then what this data mining, in fact, this particular technology was developed by a group in IBM, where they had a software which developed for this kind of analysis in the late 80s and early 90s, where they had tried to explore beyond a normal database analysis, transaction analysis. So, they looked at this kind of database table, and they find out that if you look at lot of such transactions, you can observe certain patterns in the form of rules. We call them association rules. What are these rules? Maybe we can find out a pattern that people who buy diaper also buy beer. People who buy milk and bread also buy eggs and coke. Okay. So, each of these is an example of what is called an association rule. There are two parts of each rule. The left hand side is a item set, that means a collection of items, say diaper or milk and bread and so on. The right hand side is also a collection of items. It is a eggs and coke and so on. So, now the question is, can we find some association between these two item sets? Can we say that whenever people buy milk and bread, people also buy egg and coke? Okay. So, kind of this left hand item set and the right hand item set, they would be always found together in a particular market basket or a transaction. So, you can see in the table to the left that for example, milk and bread, whenever people bought in the 4th and 5th transaction, they also bought maybe coke. In this case not, in this case maybe diaper, both of the times they bought. Similarly, whenever people bought diaper in the 2nd and 3rd and 4th and 5th, they also bought beer, most of the time, 3 out of 4 times, not always, but most of the time. Okay. That means, there is a co-occurrence between the left hand item set and the right hand item set. What is the co-occurrence? Co-occurrence means, so if you look at lot of market basket, those trolleys where people buy an item and then check out, if you look at lot of those trolleys that customer had bought, if you have found out the left hand side, you might have also found the right hand side is also there. They are bought together, left hand side and right hand side are together purchased. Now, this kind of patterns had some commercial significance. For example, I could have given some discount opportunity that if you buy beer and bread, you can buy milk at a discounted rate, or I can place the racks where beer and bread are kept together with the racks where milk is kept. So, people will buy them. Okay. So, this kind of association rules have lot of significance. Note that I am explaining this with respect to a market basket, but this kind of co-occurrence happen in many other instances. For example, if I buy a train ticket, I always buy following up by a taxi ticket or something, or if in some stock, some set of stocks go up, another set of stocks also go up. Okay. So, this kind of associations are present in many type of data. So, what we will see now is that given this set of transaction, millions of this kind of records of this what people have purchased, can I find out that what are these kind of valid association rules that one can extract from this market basket transactions? What are the valid rules that one? Note that everything is data driven. You cannot hypothesize as a rule. You can say that in this data, that is the fundamental principle of data mining, that in this data this kind of pattern is present. Similarly, in this kind of transaction, this kind of association is observed or present. So, let me now tell you a set of steps to find this. The first steps towards discovering these association rules is to detect what is called a frequent item set. That means, item set I have already defined, it is a collection of items, say bread, butter, diaper and eggs. This is a collection of items, and frequent item sets means I want to find out which set of items are popular. They are purchased by a lot of persons, they are popular. For example, bread and milk is a popular item set, whereas maybe cricket bat and ball is not so popular item, not so frequent items, and most of the people do not buy cricket bat and ball. Maybe bread and milk is more commonly purchased. So, here is the definition: a collection of one or more items is be called a item set. Particularly I would call it a k item set if it is a set of k items. So, milk, bread, diaper is a 3 item set. Okay. So, now for each of these item set I kind of measure its popularity, its frequency, how common it is, how commonly it is purchased. That count, how many times it is purchased, is called the support count of that item set, denoted by sigma within bracket item set. It is called the support count. That means, out of total all the transactions that you are observing, how many times, in how many transactions these two item sets are present. So, you can see that if you consider these 5 transactions, your support count of this item set milk, bread, diaper 3 item set is actually 2. You can see it appears in milk, bread, diaper, appears in milk, item number 5, item number 4. Item 4 and 5 contains these 3 item sets. In other words, these 3 item sets is a subset of these 4 and 5. So, it is 2. So, out of 2 out of 5. What we do is that we kind of normalize this support count by the total number of transactions. So, the support of an item set denoted by S is the fraction of transactions in which this appear. So, in this example milk, bread, diaper, the support is 2 upon 5. You might express this as a percentage also, maybe 40% is the support in this case, 2 of 5. So, next what we do is that we set a threshold of support, call it min support, min sup. Okay. Maybe 40%, maybe 50%, maybe 10%, and we say that any item set whose support value is greater than this min sup, we denote it, we call it frequent item set. So, maybe your min sup, if it is say 30%, then milk, bread, diaper would be considered as a frequent item set, because it appears in 40% of the time, which is more than 30%. Okay. So, to summarize, a frequent item set is nothing but a set of items which appear more than min sup fraction of the total transactions. Min sup has to be set by the user. If your set of transactions are very large, maybe in millions, a typical value of min sup is maybe 1%. Okay, 1%. Okay. So, let us define what is a association rule. So, as I have already mentioned, it has a left hand item set and a right hand item set, x and y in this case. Here is an example, x is milk and diaper, y is beer, and we say that in order that this particular association rule x associated with y is valid, then two conditions has to be satisfied. One is that both x and y has to be frequent item set. Okay. That means, say if we consider the rule milk and diaper associated with BR, the set milk and diaper has to appear in more than min sub transactions, fraction of transactions. The item set BR also has to appear in more than min sub fraction of transaction. Both has to appear, say if min sub is 30%, more than 30%. So, the first condition, two conditions has to be satisfied. First condition is called the support condition. It says that both x and y has to have more than min sub support. In other words, both x and y has to be frequent item sets. That is the definition of frequent item sets. There is a second condition that this should satisfy. It is called the confidence condition. What it says that in addition to x and y appearing in lot of transactions being frequent, in most of the transactions that x appear, y should also appear. So, suppose if I set a condition threshold of 90%, it should say that in 90% of these transactions where x appears, y should also appear. Okay. So, if I define with explain with this example, suppose I have this rule milk and diaper to BR, this association rule, and the support factor of the left hand side is 2 of 5. So, total 5 transactions, in 2 out of them milk and diaper and BR appear, 4 and transaction 4 and 5 they appear. So, 0.4 is the support factor. What is the note that one thing I have you make a small note is that the condition for support I stated that both x and y should appear in lot of transactions. So, how do I relate that to the definition of frequent iteration? It says that x and y taken together, x and y taken together, in this case milk, diaper and BR together, this 3 item set, 2 item set plus 1 item set, 3 item set, the support of that is greater than the threshold. So, support of milk, diaper left hand side plus BR right hand side, this 3 item set is 0.4, 2 by 5. Okay. The second factor is out of how many times the left hand side appear, what fraction of them the right hand side also appear. So, it is the ratio of the support count of all 3 together, left, right, milk, diaper and BR, divided by only left, the support of only left. So, support of milk, diaper, BR divided by the support of only milk and diaper. So, let us see, I have already calculated that milk, diaper, BR appeared 2 times out of 5 and milk and diaper appears in transaction 3, transaction 4 and transaction 5. So, 3 times. So, 3 is the denominator. So, the confidence factor of this rule is 2 by 3, 0.67. So, if I look at this particular rule milk and diaper associated with BR, let me tell you the steps. First I calculate the support of that rule. How do I calculate the support of that rule? I calculate the support of that rule as I take both the left hand side, count how many times it appears out of total transaction. Then I calculate the confidence. It is the ratio of how many times all 3 appear to how many times only the left hand side appear. Only x appear or times x y both appear divided by the times only x appear, and support is the times x y and y both appear. Okay. So, this is the support S of this rule and C of this rule. Now, what I will do is that I will call a rule a valid association rule if both the support and confidence that I have previously calculated are greater than some user supplied threshold, in this case min sup and min conf. If both are greater than this, I would call it a valid association rule. So, suppose my min sup threshold is 30%, 0.3 and min confidence threshold is 0.5, then this rule would qualify as an association rule. Okay, it qualifies as an association rule. Okay. So, what is the meaning of this? What is the meaning of this physical meaning? That means, for one particular rule to be a valid association rule, it not only has to be popular, it not only has to be frequent, it also has to be valid. That means, it also has to have high confidence. That means, most of the time left hand side is bought, right hand side is also bought. Okay. So, even though it may be true that most of the time cricket bat is bought, cricket ball is also bought, it is not a valid association rule, because the total number of times cricket bat and ball are purchased is much less, is below the support threshold. Whereas, maybe milk and maybe rice, they may be individually bought a large number of times, they may satisfy the support threshold, but they are together not bought, do not satisfy the confidence threshold. So, that is also not an association rule. Okay. So, it has to be popular and it has to be confident, valid. As you can understand, it is only then when the rule will have some meaningful pattern, some meaningful commercial use. Okay. So, now let us say that how do we discover these rules? I just give you this table, I just give you a big transaction table like this, millions of such transactions. From them, how do I extract these rules, discover these rules? In other words, how do I find the pair of item sets x and y and check whether they satisfy the support and threshold confidence criteria? The simplest way to do that, as you can think of, is that you take all possible combination of items. So, if there are say 100 items in your that are sold in the shop, in the store, you take all possible values of x and y, milk, bread, butter, milk, diaper, coke, all possible combination you take, and try to form all possible rules. We will call them as candidate rules, all possible rules. And for each of this rule, you run through the database, run through this table and check whether the left and right hand side, how many times they appear, the counts. Okay. How many times the left and right hand side appear. And after finding how many times they appear, you find out their support value from this definition, you find out their confidence value. If the support and confidence values are above the threshold values, then they are rules. Well, this approach is definitely going to give you correct rules, but the problem is it is computationally prohibitive. Why? Because suppose there are 100 items, how many possible x you can make? You can make 100, choose 10 2 to the power 100 x's, similarly 2 to the power 100 y's, or 2 to the power 100 into all possible 2 to the power 100 plus 1 different combinations of x and y's you can take. So, x and y combinations you can take, and that is a large number, 2 to the power 100, very very large number, and each of these possible rules you have to go through the entire database, which itself is very big, and count how many times each of these rule appear. So, that would take a enormous time, and not just 100, a store would have thousands of items. So, it is prohibited, you cannot do it that way. So, what do I do? I have to find some more intelligent way of doing it. So, what we will do is that we will explain you an algorithm called the a priori algorithm, which will need not have so many computation, need not try out all possible x and y's. Okay. So, in summary, what I do, I have defined what is association rule, I have defined support and confidence, I have defined what is a frequent item set, and I have defined if the support and confidence criteria are satisfied, I call that as a rule. And we have seen that finding out all possible combinations brute force is not possible computationally. So, next, in my next lecture, I will explain an intelligent algorithm which will reduce this computational complexity and do it in a much faster way. So, thank you for now.